we had two different scam lotteries. To compensate that, this time we will not have our traditional lottery, also because we don't want Nicolas to know that we will sell underpriced ledger from the black market. So no lottery tonight, but you can buy drinks with Bitcoin finally in Copernico. Okay, so for the presentation of tonight, guys, please. Guys, quiet. For the presentation of tonight, another exponent of the excellence in the Bitcoin industry. In this case, as you know, as everybody that participated with Meetup Scam Lottery knows, there is an object that is very useful to keep your private key secure. That's a Ledger hardware wallet. Here with us there is the CTO of Ledger, which is the leading company in security for hardware wallets, and not just that, they are also working on other hardware application of Bitcoin. My voice is very weird. How do you? Explain that? Okay, no, okay. Okay, so. I leave the introduction to Nicolas Bacca, CTO of Ledger, that will introduce also the next product of this wonderful company. Thank you.
Okay, so hi everybody, and thank Giacomo for the invite, and thanks for for Blockchain Lab for organizing all those nice meetups. So yeah, I was there at the meetup for the scaling Bitcoin environment, and it was clearly something to be watched. So tonight I will be speaking about the Ledger product roadmap and a few things about our architecture. So it will be slightly developer oriented. We'll try to keep it over like 20 minutes, but if it's too long, so just start throwing stuff at me and should stop. The title of the presentation tonight is Make the Smart Card Great Again, because, for 4 years we are going to make things great again, so why not the smart card? So for people who are not familiar with what a smart card is, it's a nice thing with a chip that you have in your pocket and that you use for paying when you are not paying with Bitcoins. So we'll see basically why the smart card is already great, how we can make it better, and what are the shortcomings of this technology. So I'm starting with a short introduction, if it works, like that, okay, other button. Yay, so that works. Yes, that's good. So first, short introduction about what Ledger is doing. So we are doing hardware wallet for consumer products, so those kind of the nice products, so that's the latest that we have released, but I am talking about it a bit later. But to define what the company is doing, I would say that we are the trust layer between the blockchain and the physical world. So we are connecting, we are making sure that things get secure when there are some risks. So basically in the first mile when you enter the blockchain, and the last mile when you leave the blockchain. So what does that mean with more details? We are providing solutions to secure, for example, the user dealing with his PC, so that's the kind of those hardware wallets protecting private keys. If you are operating a sensor collecting data, that's a new product that we developed. We are making sure that the data you are collected cannot be full, basically, so that people cannot modify your data. If you have an object listening as well and reporting data, we can make sure that you are truly talking to this object. And when working on a server, we have some HSM solutions that make sure that everything is correct. So hardware solution, in our opinion, is the best way to make sure that the code is executed as you want, and that you can get a proof of the executed code. So we are developing solutions all over the ecosystem for those different use cases. So why did we target cryptocurrency specifically? So I'm missing some part of the title, but it will get a bit more clear with the picture. One strong saying in the cryptocurrency world is SFYL, for sorry for your loss, which doesn't mean that someone died. It just means that, you lost money and everybody is sorry, but there is nothing we can do about it. So basically, if you lose your private key in the Bitcoin space, in the cryptocurrency space, you just lost everything, your money, your identity, your assets, and there is nothing to be done.
But thank you for the deflation.
Yes, that's it. So it's a good reason to protect your private key, and that's why, as hardware manufacturer, I was working previously with very boring stuff like, well, banking cards, passports, ID, SIM cards. And it's very interesting here to work with something that people use every day and which is very important to protect. So, well, I won't teach you anything about all those people. So all those people lost money to those different, I was saying scams. No, they were just industry with small failures. We can see the same thing with Ethereum today, with, well, some other projects, IDEO and so on. But, well, that's behind us. So, first, I am still missing the title of my slide, so I don't know if this can be fixed, but otherwise, well, I will just continue without the title. So why is a smart card great? First, smart card is the best solution today if you want to scale. So scale means basically achieving cheap deployments of secure solutions. A good example of that is a SIM card. Everybody has a SIM card. There are several 10 of millions SIM cards distributed in the world every year, and they are extremely secure. So it's also the best technical solution against physical attacks. So if you want to protect an architecture against somebody who is very determined to extract secrets from it, that's the only hardware that can do that today for this price point, and for this ease of deployment. People have been investing a lot of resources in secure remote management, so it might be a bit abstract, but today when you have a SIM card, your operator can load applications into your SIM card, and it is always doing it, I mean, behind your back, typically over SMS. For example, when you are changing countries and the roaming agreements between the operator and the other operator changes, it can update it through SMS, and that's a real application update on the SIM card, because the SIM card is a computer. It might be a bit weird, you can think of the SIM card like a key, but it's a real computer executing applications. And the most common way to program application on smart cards today is Java card, which is a derivative of Java. So it's great on paper, it's great portability. I mean, it's like Java, it's write-on, debug everywhere. It's a bit similar here for smart cards, but still, it's better than not being able to do everything, to do anything. So that still makes the smart card great. Now, what we need to change today if we want to bring smart cards for the general public, I mean, and to actually be able to do something great about it, they are absolutely not made for the web. So today, you might wonder why you are paying everywhere with a smart card, but you are not paying on your PC with a smart card. So first, that's because you need a reader. That's not very convenient. And the second reason is that smart cards are designed to work in a trusted environment. Payment terminal is trusted. Your PC isn't, and if you are confirming a payment on your PC, every malware could be able to use your card as an oracle. And few banks that started application using the smart cards, I've seen people doing man in the middle for the PIN and so on. It has been a real nightmare, so using smart cards in a PC environment is really not, not convenient. They are not very open to developers as well. So I've talked about Java card. Java card is great as it's the only thing that you have. But if you want to design new cryptographic algorithms, if you want to design stuff for specific cryptocurrencies, then Java card doesn't fit, and it would be much better to be able to write your own code in C or in whatever language you like a real computer, but this is not allowed. And you can't really see what is happening on a smart card, which is a very big hassle for cryptocurrency enthusiasts. Because we support open source, we want to see what is running on our PC, and when you can't do it, well, you don't really know if someone is not stealing your key behind your back. So it's not as well a good solution, and that's something that we are trying to change. So we will see in the next slide how basically we build on the first point and we try to change the next point. Because as the great new president of the United States say, it's an easy program, and so we can build on it to change it, because words are very powerful. So,
Bitcoin me.
First, well, a small anti-advertisement, I would say, but well, I will still wave to the lovely competition because everybody, like every other company in the Bitcoin ecosystem. But just why using microcontrollers, in my opinion, is not a good idea to do security applications. First, you have absolutely no physical protection against physical attack when dealing with a microcontroller. Sometimes the same companies doing smart card and microcontrollers, and of course that let you imagine how much resources they will put into securing microcontrollers, like none. Another big issue with microcontrollers is that you cannot really issue specific chips for you. So you can't trust your code, you can't put secrets into your chip because, well, since you can't really know what is into the chip, you can't put secrets. Since you can't put secrets, you can't build an attestation around your chip. Since you can't build an attestation around your chip, you can't trust anything that the chip is saying to you. Which means that if, for example, you know that a specific firmware version is vulnerable, and you ask the chip to get the firmware version, you can't really be sure that you are actually talking to the firmware version that the chip is advertising, because the malware could have changed it in the middle. So in the end, it makes it very, very difficult to trust the solution end-to-end, and that's the main reason why, for me, it's not proper. It's not a proper solution if you want to distribute something on a very large volume. It's still an acceptable solution if you are an hobbyist, if you are a developer yourself. If you like to build your own solution, buy your microcontroller from one source, your other part from some other source, compile everything and flash everything yourself. But other than that, I would say that to achieve a worldwide deployment for everybody of hardware wallets, microcontrollers are really, really not a good idea. So that was my anti-advertisement of the day. Now I will move to the real advertisements. So these are just the latest product that we have been releasing into the market. So before that, you have seen the HW1. Thank you. So you have seen the HW1. You might have won an HW1. So thanks to your nice lottery organized by Blockchain Labs. But now we are doing we are doing better products. Sorry, so you will have to buy them. But the good news is that I can give you a promotion. I can give you a promotion call at the end of the talk. So if you leave now, sorry, you will miss it. So we have two products. We have the Ledger Nano S, which is the same with the screen that we just released, well, a few months ago, but it's already working quite well, and yeah, thank you. And we will be releasing by the end of 2016, we already have a developer version of it, a quite similar product with a larger screen and Bluetooth. So well, one of the advantages of Bluetooth is that we will be able to use it with the iPhone, typically, and it will be great because there are not many hardware wallets working with the iPhone today. So we are releasing those products, and we'll see that all our products are built on the same platform, which makes it very portable for developers. So another example of something that we have been advertising, so not for the consumer market, it's more for the industrial market. So that's a new thing that we call a hardware oracle. So the idea is to make a device that can help you trust your environment. So you have a lot of sensors in the IoT world, and here we are designing a sensor which can protect itself. So you have a secure element that can analyze data sent back by the sensor, and the sensor itself will have some anti-tampering solution so that if you try to modify the sensor, if you try, for example, to move the sensor, let's say if you have something that records the consumption of your engine and you are trying to cheat on the consumption of your engine, to take a famous example, a secure element could be able to detect it and could report an error in that case. So we think that it's a use case that is getting to be very common in the industry in the coming years as we want to achieve more secure IoT solutions. So that works well to write things into the blockchain, but it could also work for any kind of solution managing data and needing to have some security on those data. So our architecture, which is the same for all the products, so the Nano S, the Blue, the hardware oracle, is based on a simple design, so involving one secure element and one non-secure element. We always use the secure element because of, well, we think that it's the best hardware solution today, but the problem is that the secure element doesn't have a lot of I/O pins, so a lot of way to interface with other hardware. So for that we use a generic micro, but we don't put any kind of sensitive logic into the secure micro. So secure micro listens to the events sent by the hardware, report them to the secure element, and we pair the secure element to the secure micro at boot, which means that we check the firmware of the non-secure micro by the secure micro, making it sure that we are running on a genuine device. So we build a genuine device out of one secure chip and one non-secure chip, and we use the best capabilities of both to do what we want to do. So here, one important also thing is that you have direct control over everything in your own application, which means that typically, if you are building an application which will interface with your PC over USB, you can define your application to let the device be everything, anything you want. So if, for example, you want to simulate a mass storage device which encrypt files when you write those files on this device, you can write an application to do that. You have total control about what your application is doing. To take an example of what exists today in the Java card world regarding application isolation, so Java card is a virtual machine. You build application on top of those virtual machines, and all applications are isolated. So all of these blocks here are kind of what we call the security domains. They are paths for applications. So each one of those security domains will hold application, and each application is isolated by each other by this wall, which is an applicative firewall, but everything is managed by the virtual machine and the applications. So that's kind of the state-of-the-art architecture that we have today in Java cards. How can we improve that? So we are suggesting in our architecture to do some things that use the latest properties of modern hardware to do something better and to let you write application in native code. So rather than Java, we are advertising the first solution where you can write your application in C code and you can write them on a secure element. So I don't think this has been done before, so it's interesting for developers. And the idea is that we split the code into two parts. So one user part where you are going to run your application, and our microkernel runs in supervisor mode of ARM, which means that it's completely isolated from the other application. And every time you start an application, the memory will be locked to the region that your application is using. So for each application, it looks like the chip belongs to the application, even if it doesn't. But we can completely simulate that from the application point of view. And when the application wants to access to user data, it has to go through the kernel, through a system call. So system call is a logic to switch from user mode to supervisor mode, which will check the parameters and we can enforce additional logic. So you are sure that any application that you put on your hardware wallet cannot interfere with each other, because each one of those is booted in a different way by the kernel and can't steal your data and can't export your private keys. Yeah. So I spoke a little bit before about how on a microcontroller you are not able to know what the chip is doing. Here, with this architecture, we can put a root of trust into the chip. It's a secure element, it belongs to us, so when you receive it, you can know that the key that we put into it is not easy to retrieve and is not easy to copy by a third party. So we can establish a root of trust into the device, which means that we can do a simple cryptographic protocols when we perform a key exchange between the host or the server and the device itself. So we can have an end-to-end trusted path and trusted secure channel between the host and the device or the server and the device. So if we want to deploy something, if we want to check what the chip is doing, we are sure that we are talking to the right chip and we are sure that we are talking to the right application. So we can completely verify that the device is genuine that way, which is a very standard way, of establishing a secure channel, but it's not possible to do that if you can't guarantee a secret on your architecture. So based on this, we can build a secure app store. Secure App Store means that you have application on the device when you receive it is empty, and you can load additional application on top of it. So here, for example, on the device today, we have a Bitcoin wallet, Ethereum wallet, we have an OpenPGP application, we have a U2F application, so for identification, but we can design the isolation layer to cut all those applications into different parts and to lock them into different derivation schemes. So if you're familiar with HD Wallet, SD wallets work from deriving from the seed different paths to exchange keys. Here we can say we know that this application will only derive on this path, which means that even if you have a bug yourself into your application, we can be sure, so guaranteed by the microkernel, that a bug in this application cannot compromise any other application, because the kernel, for example, will prevent the Ethereum application from deriving into the Bitcoin application. So if you have an Ethereum bug for whatever reason, you know that your keys cannot be, you know that your Bitcoin keys cannot be stolen. So that's again one strong feature of the isolation. We don't only isolate application, we also isolate what application can do with the keys. Being able to install and delete application on demand also bring a nice use case, which is, I think, quite innovative for hardware wallet. We can think of disposable applications. Space is limited on the chip, so we can't put a lot of applications, and we might have some applications that are only used from time to time. So we might want to install them, do something, delete them, and I think a good use case for that would be sweeping a paper wallet. Well, let's say you have a paper wallet from your cold storage, you want to put it into your hardware wallet without compromising your key. You can enter it directly on device by installing this application, transferring it into your common wallet, then it's done. You can delete it and keep using your wallet. So, well, that's why I think this App Store model opens a lot of new use cases. So, as just quick summary about what we said on the security part, everything is authenticated. Secure element authenticates the MCU. If you try to flash something, you will get warnings at different levels. Applications are secure themselves, and application can be locked to different paths, which means that one compromise in one application will not compromise the other ones. So we have a blog post here that describes a bit more our security solution, so that you can refer to. I will tweet something with the slide after the presentation. So if you are interested into knowing more about this architecture, everything is described here. We say that Java card is portable because it's Java. We are trying a new scheme here. We are doing source code portability from C. So how are we doing that? When we are installing something on the secure element, we have some source code with some internal API. You can cross-compile this code to run it on the secure element, so everything is ARM-based, so it's easy. When you're dealing with another kind of secure enclave, like an HSM or SGX, which is virtualization of the solution, then you still have the same source code, but you compile for a virtual CPU called Moxie. Moxie is an extremely simple CPU that runs a bit like a virtual machine, but it's quite convenient to port on different architecture. And in the end, you have completely different binaries working on the two architectures, which are not exactly as secure, but well, still, it's a good approximation. But you have the same source code. So supposing you have your source code that you compile yourself, which is interesting for cryptocurrency enthusiasts, you can guarantee that you can run the same thing on all the architectures that we support. Now, we say that the smart card is not really used for the web because you can't understand what you do. So how do we solve that? We solve that with the screen and buttons. So the screen lets you display what is happening actually on the device, so malware cannot fool you. And buttons let you confirm the user presence, so let you confirm that someone actually verified the transaction. So if a malware tries to do something, he won't be able to fool you, he won't be able to simulate what the user is doing. Another use case of here, installable application is that you can install an application to fit a specific use case. This is very important for Ethereum, typically, where you can have smart contracts that interpret data in different ways to do very different things. If your hardware wallet is just saying, okay, this is the data, you're not going to understand what is happening, and so the screen is basically useless. With multiple applications, you can fit this, you can install an application that will deal with a specific contract and let you know exactly what is to be done, displayed in a very user-friendly way. We have an example for that, for a splitting contract. Well, might not be the best use to the best example up to date, but still interesting to read. Now, another problem with the smart card is, well, drivers and middleware. So we are trying to build a plug-and-play device. We are trying to build a device that works without any driver, and we have some major technical challenge for that. So first, we can be a generic HID device, so we don't need a driver, so that's fine. But that's only solving one small part of the problem. Then we need to communicate to the device, and if possible, without installing anything. So the best way to do that is to use the web browser. And unfortunately, communicating with a USB device over a web browser is quite complicated. So we thought we found some solution and some relief when Chrome introduced Chrome apps that enabled USB communication. But unfortunately, because life is hard, Google decided to deprecate Chrome applications, so we have to start again from scratch. So that's a long history of failure. I mean, we have been doing that previously with ActiveX, Java applets, plugins. I've been fighting with that since 2002 approximately. So yeah, smart cards have a very difficult life. But I think I found a solution, so I will explain then what I can do. The solution comes from something completely different, but which is starting to get integrated into the browser, called U2F, or Universal Second Factor, something pushed by the FIDO Alliance as a standard, with Google supporting it.
Sorry, Universal? Universal what?
Second Factor.
Okay.
For 2F. Weird, but yeah. So, sorry. So this standard is based on hardware cryptography. The idea is to use very simple cryptography to identify a user and to replace the old second factor, which can easily be phished, be stolen by something else, or rely on SMS, and so are very untrustworthy. So the idea is that when you want to register to a server, the server will send you an application ID, your device will generate a key pair, and will send back the public key and the encrypted private key, so the encrypted private key can only be used by that device, to the server. Why is it doing it that way? Because then you can have a stateless device, and you can store an infinity of websites on the device. So it's quite a smart idea, because you can have one key that handles a lot of different websites, a lot meaning all of them. So it's it's a nice standard. If you're interested, you can look into it on FIDOalliance.org. Didn't write the website, sorry. So that's the registration. For the authentication, you do a challenge. So you send basically an application ID, you send back the encrypted key ID, and you get a signature. So that's very nice. You might wonder why I'm talking about that when I am talking about generic communication, but then the answer is coming. We are sending an encrypted key ID. If we cheat a little bit, if we tweak the standard, if we hack around, well, an encrypted private key can be anything. So what if instead of sending a key, we send a command here? And what if instead of sending back a signature, we send a response? We have a proxy here. We have kind of a transparent proxy we can use to push our own applications. So if we tweak the standard a little bit to be able to handle that kind of very unusual use case, we fixed our problem. And that's what I did, so I started to do it with Ethereum. Tested with MyEther wallet today, so which is quite a very popular web wallet, so which has some security problems because a lot of people are creating clones of MyEther wallet and scams, which steal the user private keys. So with this tweak and our device, we can connect without installing any other application. So we have a direct web communication between our device and MyEther wallet. And since it's successful and working well, we will push that for all our other applications. So we push that for Bitcoin, and you can use this in your own applications so that you have a native communication for the device in Chrome and Opera and Firefox soon. Now, if you're a developer, I hope, because otherwise you probably already killed yourself, so that's okay. I am just... so I'm just sharing a few links that can get you started. The most important link is our Slack. So if you want to start developing with our device, I would say join our Slack, because I know that our documentation is lacking a bit, and when I say a bit, it's a lot. So we are always ready to help you, and we like to talk to developers. We have people developing some very interesting and new application using new cryptography. We are welcome through, well, yeah, everybody is welcome. I mean, even people working on Monero, for example. So yeah, so really just come and and talk to us. We are friendly. Very to finish, very quick overview of the applications that you can find on GitHub. So you can find a Bitcoin wallet. So everything is open source here. So Bitcoin wallet is integrated with Greenadox, Winbits, Copay, Electrum, Mycelium. It's a code that we use as a base code for all our other Bitcoin applications. So typically the Oracle is based on the wallet, and you can even, if you want, I think we'll publish this code at some point. You can have a hot wallet, which would be something working on a server and making sure that you are not spending more than what you are ready to spend in your hot wallet. So that's an example of using the device as kind of a very small HSM working on a server. We have an Ethereum application, which is a code used for MyEther wallet and can be used as a base code to deal with all other contracts. So later we'll have our token contract based on that code. We have an SSH PGP agent, so that's kind of very simple cryptographic code that will be replaced by something a bit more complex. So still, if you want to get into development, I would say it might be a good suggestion because the code is much more simple than the others. It will just be phased out, but well. And the U2F client, which is also simple, so just that's the applications that you have today. So if you're not a developer, you can download them on your hardware wallet from our Ledger Manager application. But if you want to recompile them, rebuild them, tweak them, you can. And finally, last big part, if you want to change the common behavior of the hardware wallet, if you want to have a new personalization API, new pins, if you want to change basically the very low-level behavior of the hardware wallet, you can do that with an application as well. So it can be done in a very safe way. If you mess up, you can always recover. So you don't have to be afraid. I mean, that's something you can try if you want to try some UI or to try some new thing. For example, ourselves, we did it first to change the pin order because we got some complaints that the pin always starts by 5. I mean, we always let you cycle by the pin displaying starting at number 5, so people say, okay, that sucks. Well, so we shuffled the pin, so we shuffled the pin, for example, to prevent against that. And another use case, we implemented Electrum seed support, so which is kind of a mixed BIP39, so it uses the BIP39 dictionary, but it's implemented differently. So we use that to implement this as an example of what could be done with dynamic UIs. Now, almost there. What's coming soon? So we have a password manager, a way to store your password on your ledger and type them back as a keyboard, which means that it can work without any application on the host, and it should be able to work on iPhones, which is very nice because it's quite complicated to use a USB device on an iPhone. But if it's a keyboard, it should, and I'm confident. We have an OpenPGP standard card application, so working as a CCID standard that will let you import your own PGP keys, so including RSA up to 496, so that's good as well. We have the Bitcoin wallet integration in the browser that I talked about, and an ERC20 token support for Ethereum that will let you verify what you are transferring instead of displaying some weird data, which is doing today. So it's better than nothing, but well. And that's it.
First question by someone that already had a PGP key in the 90s.
Okay. I would like to introduce myself, and with the permission of Nicolas, I would like to pass to Italian, if I can. Ritengo che non sia stato facile seguire quello che ha detto Nicolas, perché in questo mondo molto avanzato Nicolas è 2 passi avanti. L'ho conosciuto nel 2013 a San José e mi pregio di conoscerlo da allora e di averlo seguito durante tutta la sua storia. con tutte le sue novità in base di hardware, ha sempre fornito una sicurezza che era almeno un passo avanti rispetto a quella di tutto il resto dell'industria. Quindi il Bitcoin non è una questione di fiducia, è una questione di verifica. Però se vi fidate di quello che vi posso dire io, che seguo il Bitcoin dal 2011, vi garantisco che, essendo appassionato, avendo studiato, Nicolas è veramente almeno sempre un passo avanti rispetto al resto dell'industria.
So don't verify, trust. Trust.
Esatto. Don't verify, trust.
Not a good advice, but yeah.
L'idea di base che lui ha omesso perché immaginava che fosse scontata, ma ve la dico io, è che i computer non sono uno strumento di sicurezza, non lo sono mai stati. Perché? Perché i loro sistemi operativi sono conosciutissimi dagli hacker, sono molto accessibili e sono normalmente connessi. Quindi esistono virus, malware e qualsiasi cosa che può entrare dentro il vostro computer. Lo sa benissimo chi ha subito degli attacchi di malware o di ransomware, cioè quei virus che vi crittografano i file e vi chiedono i riscatti in Bitcoin. Ora, qual è il vantaggio delle soluzioni di Nicolas? In quei device piccolini, molto piccolini, che adesso vi posso far vedere forse, no, li ho persi già. In questi device qui era chiuso un computer estremamente specializzato ed estremamente piccolo, perché più è piccolo più controllabile, e più è controllabile più è difendibile dai virus. E non è mai connesso a meno che voi non lo connettiate attraverso un'unica porta che è l'unica disponibile. Quindi ci sono alcune ragioni per cui fidarsi di una soluzione di questo tipo. Tutto ciò che fa e tutto ciò che può fare è comunque sottoposto alla review, alla revisione non mia, che non ne capisco una cippa, ma di migliaia di developers in tutto il mondo. Non sto vendendo i suoi prodotti, ma li sto seguendo da anni e sono commosso che lui sia qui ad illustrarli. Io non so quanti di voi abbiano capito tutto quello che ha detto, io purtroppo ho capito solo il 30%, però mi sento estremamente privilegiato di averlo ospitato qui. E sinceramente la mia non è una domanda, ma è semplicemente una manifestazione di grande affetto, perché quello che ha fatto lui per il mio patrimonio in Bitcoin e per il mondo del Bitcoin in generale è insuperabile. Io ti ringrazio, Nicolas. L'unica domanda che ho è: quando è che sarà possibile un aggiornamento del software? When will be the estimated time of arrival of the next upgrade of this beautiful new product?
Thank you for the question.
As you understood, the way to ask in Italian when is the update available is very long, so it's a strange language.
Well, I would say that we are so continuously, well, yeah, that's a good politically correct answer. We are continuously working on updates, and the nice way with upgradable application is that we can update all applications separately. So we can basically release a new application every week if we want, and people can just install the latest application they would like to install. So we expect to have the PGP application by the end of the year, the password manager by the end of the year as well. And next, I would say low-level updates, so introducing more cryptographic algorithms and introducing, for example, passphrase support directly on device, so you will be able to diversify your HD wallet directly from the device, so you won't need to type a passphrase on the computer by, I would say, beginning of the next year.
Okay.
So that's, yeah.
Thank you.
And yeah, before I forgot, for people who are still here, yeah, I promised the promo code before. So the promo code is ChainHack, like chain, like hack, all capital, 2016.
Chain
yeah.
Hack
Yes.
2016.
Just for you and not for other people.
Just for you.
I would like to ask if you could try to explain later what is really forbidding for using the secure element in a SIM card or a secure element in the Android operating system to achieve most of what you're doing with your hardware? I mean, what is the real block, the real roadblock on that?
The first roadblock is that most of the time, so those secure elements are running Java card, but that's not really a problem because we have, for example, an implementation of our wallet that works on the Java card. So it behaves very bad. I mean, it's very slow, but still it's doable. So that's not the main roadblock. That's not really a technical roadblock. The real roadblock is commercial because people don't want you to install your own application into the secure elements. It's always very complex. The secure element either belongs to the manufacturer, for example, in the case of Android, or belongs to your operator, to your carrier for your SIM card, and they just won't let you install an application inside it because it's their way to access the network and it's their way to monetize, I would say, for value-added services. So that's mostly a commercial reason.
But so we could have
Could we have a smartphone, a dual SIM smartphone, where the second SIM is just used as a hardware wallet owned by you and using your technology or something like that? I mean, looking forward.
Yes, you could completely do that, and you could even do something else that's already possible today. You have some technology called proxy SIMs. That's something that is pushed by another company called ZSIM, I think, in the ecosystem. So Chinese manufacturers have gotten very good at that. One of them is called Tasis, the other one is called Watch Data, for example, and they are selling you some SIM cards, basically some open SIM cards that you can put on top of your SIM card. So they act as a man-in-the-middle device between your phone and your SIM card. You can load your application on this device, and when a request is coming to basically talk to the network, the request will go to the real SIM card. So it's something that's not very well known. We call that proxy SIMs, but it already exists today. So you don't even need a dual SIM. I would say you need a proxy SIM to put on top of your SIM, and then you can have an application that do whatever you want. So it could be a Bitcoin application. Again, if it's Java card based, it won't behave properly. If you want to do some Ethereum, if you want to have an Ethereum hardware wallet today, it's just not possible to do it on a Java card because of the cryptographic choices taken by the Ethereum community. For the SHA, for example, they are using SHA-3, but they are not using the final version of SHA-3. They are using KSAC, which is the version that went out before the official standardization. So you are not going to find this algorithm implemented as a standard today in a modern secure element. So that's also one of the multiple reasons why we write our own operating systems, because then we can choose what cryptographic algorithm we put on that, and we don't have any constraint.
So you could use proxy SIM for your solution?
Yes, we could. Yes. We could use proxy SIM for our solution, definitely. We have been looking into it. We don't spend too much time into it because then you have other problems. The other problems are basically the user interface, because you have to talk to the proxy SIM, you have to display some kind of UI which will look very bad, and so on and so on. So there are many problems, but yeah, we could use it.
So is the proxy SIM essentially a separate secure element?
Yes. It's a secure element with additional contacts that you stick on top of your SIM. It's really a man in the middle. It's a commercial man in the middle.
So the only advantage is that you don't need a dual SIM card phone. Right?
Yeah, you don't need a dual SIM card phone if you want to use a proxy SIM.
Talking again about secondary secure element inside your cell phone, you are already interoperable with the inside cell phones. What are the main reasons to avoid to use the T inside the cell phone as a primary hardware wallet, if any? And how do you see in the future maybe the security of our keys passing to the T or staying in a separate device?
Yeah. So Oh yeah, that's a very good question. I think that in the future we will probably see more and more solutions switching into the TE, so as kind of a virtual secure element. So there are two problems, I mean, for Bitcoin people when choosing to use a TE instead of an external security device. First thing is that it's very difficult to audit what's running into the TE. So the code will be often encrypted by the manufacturer or the supplier of the TE before being loaded. So you have no idea what you load into your TE, and well, Bitcoin community doesn't really like that. The other problem is that the TE is purely used as an isolation for malware running on your phone. It doesn't bring any level of physical protection. So if you have an attacker which can basically take physical control of your phone, the TE is mostly useless. Because by flashing the firmware or by deciding to change a few of the properties of the phone, it's very easy to get the TE to basically disappear and reveal its secret. So it fits a very narrow niche, but which is still important, of protecting your keys against malware. That's still I mean, one of the biggest risks today when you have a mobile phone. But if you want to protect against malware and physical attacks, you can consider the TE.
What do you mean by TE in this case? I mean, this is not Qualcomm QSE. You are talking
it would be some, what do I mean for TE in that case? It would be some kind of higher level architecture that lets you run your own application on top of TrustZone. So TrustZone is providing the basic isolation services. You write either yourself or you use some kind of environment that is given to write your own application. Voice is weird, but that's okay.
What about real TEs that are coming on with other installation, like the Qualcomm solution QSE that we have in like Nexus 5, Nexus in the Pixel device?
For me, they are still just using TrustZone. I mean, they are not. So yeah, so it's still hardware isolation in that case, but for me, it's TrustZone. It's just some small operating system on top of TrustZone. If it's something else, then I'm not aware of it.
Other questions?
Could you elaborate more on how could you said that you can share the same seed on different networks like Ethereum and Bitcoin, as far as I understand. Okay, how could you do this if you are splitting the memory between apps in a secure way? I mean, how does it work under the rule?
Okay. So the way it works is that only the microkernel has the seed as the initial seed. When the application wants to derive something, they send a request to the microkernel with the derivation path that they want to derive. And when you install the application, you put some metadata along with the application code that says this application is authorized to derive on that path. So when the microkernel passes control to the application, it will verify that the path asked by the application matches the path that has been signed when you install the application. So if at some point you manage to gain code execution to the application and to change the path that you will give to the microkernel will reject you because you are not talking with the path which was signed in the metadata of the application. So we solve it basically by not allowing the application to access the seed directly. It's only accessed by proxy of the microkernel.
And the seed is at the upper level.
Yes.
Other questions?
No one asking. Is using a Bluetooth on iPhone device provide the same security as using a USB cable?
Technically, no. Functionally speaking, yes. I mean, the only issue that could happen is that somebody could spy on the communication between your device and your Bluetooth device. So somebody could see what you are signing. So somebody sitting near you and spending a lot of time could basically see that you are sending a transaction of this amount to this address. That's all. That's it. That's all.
So privacy concern.
Yeah, minor privacy concern compared to the time it would take for someone to decide to attack you specifically.
Speaking about the HW1, is it still running bots, or can we run applications, the application you were mentioning before, on HW1, or is it a completely different architecture?
Yeah, so, well, HW1, unfortunately, is completely different. It's running on a very old chip. HW1 has a very, very complicated history. It's basically a project I recycled and I saved from another project which failed and so on and so on. So it's, well, it's basically a miracle that we managed to do that. Yeah. I would say that the original HW1 was signing a transaction in 30 seconds. And it took us 1 year to optimize it to sign in less than 1 second. So yeah, that's basically the state of HW1. So it's a product that will be phased out at some point. I mean, basically when we finish selling the stock. And then the nice part is that we will very likely be able to move to a similar architecture to the new HW1. So we'll probably at some point launch a new HW1 using the Bolos architecture that we have with the newest one. And then we will be able to load our own applications. But yeah, for the time being, it's really our first generation product. We are still updating it for important updates. So for example, security updates. If at some point we have a problem, then of course we will update it. We have a firmware update pending for SegWit when it activates. So that's, well, so we are not letting users behind, I would say, but capabilities are extremely limited compared to our latest product.
Is it a secure element? Or
Yeah, it's a secure element.
Or just a secure element?
Yeah, it just...
There is no microcontroller? Right?
No, but it's an extremely old secure element. I mean, to do a quick comparison, HW1 is an ST7, so it's an old chip which is basically an 8-bit chips are running with a 16-bit data bus, so it's not very powerful. It's technically running at 20 MHz, but since we are using a hack to run into the A2PROM instead of the ROM, our clock is divided by 2 for some reasons, so we are basically running at 11 MHz. And we have 72 kilobytes of A2PROM to run our application. And, well, 2 kilobytes of RAM, I think. So that's, yeah, so that's not really the same thing as a very modern ARM chip with 400 kilobytes of flash, 10 kilobytes of RAM. It's completely different.
Other questions? I will ask the last one. Since the model of Ledger, the security model of Ledger, involve an initial very little part of trust on the side of the producer of the secure element itself. What is, in your opinion, the best practice or the best scenarios that we could imagine, both on the side of the user behavior and on the side of overall industry behavior to further limit this risk and or further move it in a more decentralized way? I mean, how do you think we as a community address the risk of not trusted secure element producer if this stuff goes mainstream?
I think it's difficult to fix today and the secure element providers themselves, because, well, it's a business that has been running this way since I would say since the beginning of time. So, well, at least the beginning of secure elements. So it's a trust model that has been working like that since the early 80s. So I don't think it's going to change. If we want to look at it on the bright side, I would say, well, of course, more audits from the community are always welcome, because then you can check that, well, you can check, for example, try to break the chip and see if there are some backdoors into it, which is still extremely unlikely, but, well, because I think it's unlikely because I don't see states trying to hack the things that they are using themselves to protect themselves. It seems a bit weird to me to think that they would do that, so that's just my personal opinion. If you want to have an opinion which is based on logic rather than ideas, I would say, there are people trying to develop open secure elements today, so based on the RISC-V architecture, so the low-risk project is working on that, and I would say that supporting those people and supporting that project when it comes out, so thinking about the way forward to produce those chips in the most decentralized way and producing new ways of testing those chips is probably the way forward. So it's a very long-term strategy. I can't see it succeed in maybe 10, 15 years, but that's an extremely long-term strategy, and in the meantime, the best thing we have is the existing secure element.
Would it be right to synthesize this answer, telling that there is no way for the secure element producer to break just Bitcoin wallet without breaking all the other existing application. Would that be right? That they cannot selectively attack only Bitcoin application?
Yes, because they don't know what people are running in those secure elements. When we receive the secure element, it's personalized for our key, but well, they know what we run, but they don't see our code. That's the point. It doesn't work like the TE model, for example, or like SGX model, where at some point Intel is signing your code and Intel, or the producer, I don't want to blame Intel because everybody is doing that. So the producer doesn't see your code in that point. For a secure element, the only thing they have from us is a personalization key. They send us the chip, matching our personalization key, and that's it. They never see our code. Our code is something we load encrypted to the chip. We load it ourselves.
Thank you very much. Other last questions?
Hi. Nice to meet you first, and the question is from a user. So I'm a user of Ledger, so I have HW1 and the last one, Nano, the last Nano S. So next week I think me and my business partner, we will have a test about Ledger. So we try to destroy Ledger Nano and reinstall a seed in the Nano Nano, because we want to be sure that's work, ok? So, in Italia, cioè io sono un utilizzatore di Nano, lo utilizziamo per salvare Bitcoin, ho sia l'HW1, quindi il chip che mostra praticamente Gabriele, e l'ultimo Nano S. La settimana prossima, per verificare che funziona il sistema, noi distruggeremo un Nano S, quindi lo spacchiamo proprio con dentro dei bitcoin, ovviamente pochi, e poi ne prendiamo un altro e reinstalliamo il seed per vedere che funziona. One thing is the seed is unique for all addresses, or cryptocurrency inside. So for Bitcoin, Ethereum, it's all. We installed only one passphrase on 24 keys, ok? Cioè il nano praticamente...
Guarda che non serve che traduci, non serve che traduci.
Ah, ok, va bene. Qualcuno non capiva.
È andata già via quella che non capiva.
Ok, thank you. And we have to be... we have to save another things about Nano S, only the seeds, and we can install the okay. So how many cryptocurrency you think you can install in the chip now?
So today we have, well, I would say based on, well, if we think of cryptocurrency derived from Bitcoin, we can install as many as we want, because the same application can be derived with a different version of pay to script hash and pay to public key hash. I mean, so on Bitcoin we don't have a problem. Regarding completely different application, today you can install, I think it's 9 applications into the chip. Then you can delete one, install another, and so on and so on. And that's an arbitrary limitation we set at the beginning because our sorting code is a bit slow. You couldn't. So the real answer is that you can store as many applications as fits into the memory of the chip. So that's well, not very informative, but that's the case.
Is that support an endorsement to various cryptocurrency you support?
It's an endorsement to the number of applications we can put on the chip.
So, no other question. So, thank you very much to Nicolas Bacca. Thank you. Vi lascio liberi con prima un annuncio pro domo nostra, cosa che non facciamo molto spesso. Se qualcuno di voi è riuscito a capire non il 30% di Gabriele, ma magari un 3% di tutta la presentazione di Nicolas, siamo assolutamente interessati ad assumere nuovi tecnici in Blockchain Lab. Stiamo cercando attivamente, anche se siete delle persone che sono magari su incarichi più divulgativi o consulenziali, stiamo espandendo il team in maniera sostanziale. Quindi chiunque sia sopravvissuto mentalmente guardo in quella direzione casualmente, a una certa percentuale, è caldamente invitato a prendere contatto con gli organizzatori. Ragazzi, liberi, niente lotteria, niente legge, buona serata a tutti. Ciao!